Robotics, AI-powered machines interacting with the world. Robotics represents the intersection of artificial intelligence and physical machinery. This fusion results in machines capable of movement and interaction with their environment. These machines are commonly referred to as robots. Robots can operate autonomously, making decisions independently, or under direct human control. The field of robotics draws upon several key disciplines. These include mechanical engineering, electrical engineering, computer science, and artificial intelligence. A defining characteristic of a robot is its ability to perceive, process, and act. This capability allows robots to interact intelligently with the world around them. This functionality is achieved through three primary components. These components are sensors, processors, and actuators. Each plays a crucial role in enabling a robot's functionality. Sensors gather data from the environment. Examples include cameras, lidar, and ultrasonic devices. These sensors enable robots to see and understand their surroundings. Processors analyze the data collected by sensors and make decisions based on that information. These processors are powered by sophisticated AI algorithms. The algorithms enable the robot to plan its actions. Actuators execute the actions planned by the processor. Examples of actuators include motors and grippers. These enable movement, object manipulation, and physical interaction with the environment. Artificial intelligence integration is crucial for a robot's functionality and adaptability. AI algorithms enable robots to learn from experience. This learning allows them to improve their performance over time. AI algorithms also enable robots to adapt to changing environments. This adaptability is essential for robots operating in dynamic and unpredictable settings. Furthermore, AI empowers robots to perform complex tasks. Types of AI used in robotics range from rule-based systems to advanced machine learning models. The choice of AI depends on the specific application and the complexity of the task. Robotics has found applications across a wide range of industries. In manufacturing, robots automate repetitive and dangerous tasks. This automation leads to increased efficiency and productivity. In healthcare, robots assist in surgery, rehabilitation, and patient care. They can perform delicate procedures with greater precision than humans. Robots also play a vital role in logistics. Within logistics, robots manage warehouses, sort packages, and deliver goods. This automation streamlines supply chains and reduces delivery times. Robots are also used in exploration. Robots are deployed in deep-sea research and space missions. They can explore environments that are too dangerous or inaccessible for humans. The future of robotics holds promising advancements in AI, materials science, and energy efficiency. We can expect to see more sophisticated and versatile robots in the coming years. The lines between human and machine capabilities will continue to blur. However, the increasing capabilities of robots also raise ethical considerations. Job displacement is a significant concern as robots automate tasks previously performed by humans. The potential for misuse of robots is another ethical challenge. Thanks for watching TADHEM.